Earth is 4.5 billion years old. Impossible for your brain to truly grasp. So here's an experiment. Every second, around 1.5 million years will pass. You're on a musical train ride, looking out the window, passing all of Earth's history in an hour. Watch the eons pass and experience how long a billion years really is. You can have this in the background, study with it, or just enjoy the ride. From time to time, I'll say a few words. 4.5 billion years ago, right after it was born, Earth was a hell of lava. Pretty early in its history, Earth collides with a Mars-sized object called Theia, which forms the moon that you now see in the sky. Right now, it looks huge in the night sky and will slowly shrink over hundreds of millions of years as it orbits further away. 4.5 billion years ago, we are in the first eon of our planet, the Hadean, named after the Greek god of the underworld. At this point, the atmosphere is mostly CO2 and the floor is lava. This area of Earth's history is mostly invisible to us because almost none of it is left. "90 million years have passed. We are still in the lava hell phase. Settle in. This will take a while." Although you wouldn't think it, we found minerals called zircons that indicate there may have been some water around at this time. During this period of the young solar system, Earth and the inner solar system are smashed by a constant heavy asteroid bombardment for several 100 million years. At this point in time, our Sun is 30% less bright than it is today. But there are so many greenhouse gases that it's still much hot and comfy. Around this time, we think life begins to enter the stage. Only a few 100 million years after the beginning of everything, the first cells begin spreading over our still very deadly planet. Earth continues to cool, and it probably rains for millions of years as our oceans begin to form, covering the still young planet with water. hydrothermal vents we're looking at, and where hot minerals emerge, may have been the place where life first developed, but we don't know. So much time has passed, and we're entering the Paleoarchean. Most of Earth is still underwater, while the first supercontinents are in the making in the depths below. Its days are shorter since the young Earth spins faster. Good job if you're still watching. You've witnessed 1 billion years so far. This time in history, we still have stromatolites, sedimentary rocks built by microorganisms, among our first real evidence of life on Earth. Also, life is starting to eat the sun. Photosynthesis might have started as early as around here. $3.2 billion years ago in the Mesoarchean, the era of continents begins. Tectonic plates begin to crush into each other, pulling and pushing some deep into the Earth, where they dissolve. The basis for our continents today. The oceans are as hot as a hot tub, over 40 degrees Celsius, and microbes are expanding everywhere. We don't have plants yet to consume greenhouse gases, so it is really, really hot. You would basically die immediately in this atmosphere. Also, there's no oxygen in the atmosphere yet. 2.8 billion years ago, the Neo-Archean begins. Earth is still a terribly hostile place, but because we finally have proper plate tectonics, more chemicals are mixed in from inside the Earth, and life can use them to make new things. Sometime around here, prokaryotes like bacteria begin colonizing the planet. Life diversifies more and more. But still, after so much time, we only have single cells. .5 billion years ago in the Siderian, a massive event is about to begin that will change the planet forever. The Great Oxidation Event. Oxygen, burped out by cyanobacteria, reaches the atmosphere in large quantities, paving the way for more complex life. reacts with methane and forms CO2 and water, which rapidly cools the planet down. Probably for the first time ever, the planet freezes over and a period of multiple ice ages begins, lasting millions of years. 2.3 billion years ago, the Rhyatian begins. Lots of volcanoes heat up Earth, and Earth unfreezes slowly again. Melting ice flushes toxic elements into the oceans, but life quietly puts up resistance and keeps evolving. Sometime 2.05 billion years ago, in the Orosirian, a large asteroid hits Earth and creates the largest verified impact structure on Earth. over Earth, great mountain ranges are crushed into existence by early continents with wild names like Ur, Nena, or Atlantica. $1.8 billion years ago in the Stetherian, the supercontinent Columbia has formed. And a natural, self-sustaining nuclear reactor awakes, just from scattered uranium deposits in the ground. $1.6 billion years ago, around the edge of Calimian, plus or minus a few hundred million years or so, The first eukaryotic cells, cells with a nucleus, merge from two other cells. One of the most important moments in the history of life. But yes, kind of looks not that impressive. Still, life is only cells. Earth's crust thickens and heavy continents form. The oceans become shallower. Also, the first fungi-like organisms extend their tubular arms and do fungi things. Sometime in the Ectasian, 1.4 billion years ago, Earth's inner core is forming. Weird, right? Feels like it should be older. But around here, it begins to solidify into an iron crystal surrounded by hot liquid metal. It will only grow from now on. 1.2 billion years ago in the Stenian, not that much is going on. Except the algae Bangiomorpha pubescens might have invented sex, a big reproductive improvement for many different reasons. One billion years ago, the Tonian begins, another age where Earth is rocks and puddles and oceans. Life is still invisible to the naked eye. It does feel different to witness it like that, right? not everybody is having a great time here. We have evidence of the first unicellular predators emerging around that time. The dominance of bacteria ends, and big boy eukaryotes plant their flags in the oceans. An arms race between microbes begins that again creates huge diversity. Some even invent tiny armor. $720 million years ago, in the Cryogenian, Earth freezes over again. Sure, why not? How did life survive? We're not sure. $635 million years ago, the supercontinent Gondwana forms. A lot of it is still left today. Wow, what's happening? Suddenly, life gets big. In a hot second, multicellular organisms become widespread. It's all strange alien still, but can you imagine that it took that long for this to happen? $539 million years ago, the Cambrian explosion begins. We see life bursting with variety. Ancestors of almost all of today's major animal groups appear here, while the plants start to discover the land. Life is finally exciting. But of course, a big mass extinction happens right after, killing most species in the ocean. Plants spread over the planet and create the soil on the ground and change the atmosphere, by eating CO2. Things escalate. Flora and fauna adapt better and better to life on land. We get trees and forests. Fish and the first vertebrate decide this land thing is something they need to try out. 359 million years ago in the Carboniferous, forests and lush marshlands are at their peak. They will turn into the coal humanity burns today to keep ourselves warm. It's all so fast now. Life changes so quickly in geological timeframes. Some 299 million years ago in the Permian, Pangaea, the last supercontinent, has formed. And after a few tens of million years, the largest mass extinction in history happens, killing the majority of all species. Thanks, volcanoes. $252 million years ago, the Triassic begins. Oh hey, a dinosaur. We are now truly in the age of reptiles. Dinosaurs are everywhere. The ancestors of the birds do bird things. Life finds a way. Earth gets more and more familiar. Such a paradise. Life is thriving. Nothing can go wrong. Wait, what's that? And an asteroid killed the dinosaurs and most species on Earth. Such a bummer. 66 million years ago in the Paleogene, the continents look roughly the same as today, and mammals take over. It is our time now. We are almost home. Don't blink or you might miss all of human history. And that was it. Earth is ancient. We are new. So new. This was a project born of passion. We've worked on this video on and off since 2019, and as you can imagine, it took forever to make. But we did finish it in time for our 10th anniversary. If you want to support experimental videos like this one, please like, share and subscribe and press the bell. You can also continue your journey through time with our new Timeline of Evolution poster. Discover how long it took for the first cellular blobs to evolve into fish, then into dinosaurs and finally into mammals, and encounter amazing creatures you've never heard of along the way. This poster is part of our Education Edition, a poster series that brings complex topics to life through extensive research and elaborate illustrations. It's perfect for teachers, students and science lovers. Get them from our shop and support what we do on this channel. In any case, if you got this far, thank you so much. Hope you felt something watching this.